Okay, now let's go to function revision because since we are going to talk about functional higher order functions, so it's better to revise again. Some of you might have a problem to understand function very well. So what's function? As I told you over here, functions allow us to write maintainable, scalable, testable, reusable code, and it makes our code clean. So that's very good. Then let's create make square def. I think it's better to explain again. You need def and then a name of function, and then you need parentheses and then the colon, and then you may return some data type. It could be a number or a boolean or a list, whatsoever kind of data type. If you don't return, by default it's going to be none. Yeah, but now let's just say and the value we pass here, we call it parameter, for instance n. Instead, let's give it make square. The name of our function, we call it make square. And to make square, actually you have to multiply a number n times n, or something like this. So then any way is possible. Great. Then I can say print make square. This is how we invoke or we call. You guys do have a name, right? And if I call you by name, you may say something, yeah? You respond or you just say yes. Now I have to give it maybe 3. The square of 3 is known and it should be 9. Oh yeah, I can make use of this function over and over and over again. 30 or 2. I am expecting 900 from this and 4 from this. Yeah, great. So it's working. Okay, and a function takes multiple parameters. Yes. Def add 2 nums, A and B. And then you just return A plus B. As you can see, your function should have only one role, only one purpose. So the purpose of this function is actually just to make a number to its square. And the purpose of this function is actually to add 2 numbers together. That's the only purpose. And it's a very good discipline, or it's a very good strategy to make your function solve only one problem. Okay, don't give many tasks for your function to solve. So it's better to split your function into smaller pieces. Okay, so you guys who are testing this is a very good concept. Change your functions to smaller pieces and it will be easy to test. Okay, now print again and let's invoke add 2 nums. How about 1 and 1? Of course, everybody knows it's going to be 2, right? And let's duplicate this. And everybody knows 1 plus 4, and it's going to be 5. How about if I just add 99 plus 1? Yeah, everybody knows 100, right? Great. So this is working. Of course, if I give it weird number also, it just adds together, but I'm just making it simple for you. 451 something and plus 9 4 8. So this also will be added, as you can see. Great. So this is a function we have. Now today, how about if I ask you, Dave, add numbers? So you may have many numbers and you never know how many, let me just put it like this, print add numbers, and it may take 1, 2, 3, 4, 5, 6, 10, 9, whatever. So you never know how many arguments to pass here. If that's the case, we should say, actually, we can use the star and pass a, or params or arguments. It's args is very common. So let's just print this out and see. Print args. As you can see, since I have passed all this, maybe first I may show you by just calling this function without any value, and let's see what we get from the args. Oh, as you can see, we got this tuple, empty tuple. How about if I get back this? I am expecting all this number inside these tuples. Okay. Oh yeah. Then actually we can loop through for item in args, print the item, and let's see. Now we may see them one by one. Oh yeah, but the point is, it says add all numbers. So total, we can start from 0 and adding them one after another, right? Okay, great. So total and this plus item. Oh no, there shouldn't be. Then print. By the way, this is a short way to write total plus item. Let me just show you like that first, and then we can make. Now we can return. Have you seen the none every time? The none is coming because we are not returning anything from this function. Now I can return total, and let's see the value. Yes, the sum of all these numbers together give you 36. Great. Are you following me, guys? Can you type 1 for me? That would be nice. Then I know you are following me and get, okay, great. Thank you so much. Okay. I think this is good enough now because we are just we saw how to make use of this. This is what I was interested to show you. At the same time now, I want to show you Lambda function. Okay, Lambda function. Okay, Lambda function in other programming language, we call it anonymous function, a function that doesn't have a name. So sometimes we may not need that function. We may not need to call that function now and then. So we create it without a name using the keyword lambda. Hey, lambda, can you be X? And if I have an X as in an argument, as in a parameter, I want to return X after by multiplying 2. So this means actually doubling. So, but there is no way to call this function. There is no, because it doesn't have name. Okay, if this function doesn't have name, let me just call it nameless. I stored it in a variable name nameless. So then I may call this nameless. And if I pass 2, actually this 2 goes here, and it will be multiplied by 2, and then I should get 4. Oh, I was not printing this value. Print the nameless function. Yes, and how about if I just change this to 10? What are you expecting now? So I have 10, 2 times 10, I'm expecting 20. Oh yeah, but you can even call this whatever. But by itself, it doesn't have any name, so we have to attach it first we have to store it in some variable, and that variable will act as the name of the nameless function, and we can call it as a function with argument. Yeah, is it clear, guys? Even now, is it just x and? No, it could be, for instance, how about if it has x, y, z, and you may say x plus y plus z. And this could be also for x, for instance, if you want to see 1 plus 2, 3, if you want to know, I think I'm expecting 6. Yeah, of course, if you change this to 10, maybe it's going to be 15 or something. Yes. And if you change this to also 30, it's going to be 42, right? Because it's sum. But you can even multiply this with a number. So maybe you can make it even square. X squared plus 2x plus 1. This is a kind of a quadratic function, right? So, but since everything is x, then you need only one value. So who would tell me the value of 2? Now you tell me. Calculate it manually and tell me the value. Great, the answer is 9. You take 2 here to the power of 2, 4. And then 2 times 2, 4. 4 and 4, 8. 8 plus 1, it should give us 9, and let's run. Yeah, that's simple. This is anonymous function. This is how you make use. So now, if this is clear for you, the reason why I start reviving function, because today I will talk about higher order function. Higher order function. .py. Okay, what are these higher order functions? First, let's see the definition. Higher order functions take function, another function, take another function as a parameter, okay? Or the second higher order function, return another function as a parameter. Yeah, these are the two. So let's see, right. So maybe you can see def make square is a function. It takes something like this, right? Are you familiar with this function? We wrote this function 101 times, right? So everybody is familiar with this. I believe so. And then actually, how about if I want to make a cube? Make cube. Cube is also the same, right? The kind of return. Do you agree with this? Do you have any objection? Nope, right? This is okay. This is also okay function. But sometimes, you know, if we have some function somewhere, we can make use of the available function. So actually, if we have some value, for instance, I can say print make square, and then I can say 2. But if I multiply the value outside now after that, it gives me the cube, right? 8 is the cube. And if it's 3, and if I multiply it outside, it's 27. So I should have made use of this inside the make cube. So I can say a kind of some function. I am passing this function as in a placeholder or as in a callback. Then I can say, hey, func, can you just multiply this value and then multiply it again? Actually, this is. Then how do we make use of this? You can say, hey, print cube. Now make cube. Make a cube. No, make a cube. So inside the make cube, we have to pass instead of func. Now I have to make use of the make square. Make square. And what value do we want? 10. For instance, the cube of 10, it's going to be actually 1000. Oh no, sorry guys, I made a mistake here. N itself. In itself, because this made it square, and then if you multiply it by that number, it will be a cube, right? Yeah. And if you want more numbers, then if you change this to, you are expecting 8. If you change this to 3, you're expecting 27. Is it clear, guys? So we are making use of actually the make square inside the make cube. Yeah, this says func. You can call it whatever name you want, but when you call the make cube, you should call the proper function, the named function here. Great. I think this another way returning, for instance, returning it. Let's just corners, let's call this function, oh, sorry, I'm thinking in JavaScript now. Def higher order function, I can call it just higher order function for the time being. Then I may say, again, you can create a function, def again, def, add 10. Yeah, add 10. Add 10 is actually anything I'm passing here value n, and then this the add function. Now, what is doing actually return n plus 10. Yeah, so this is the higher order function. So now let me just return add 10. Have you seen now I'm returning the function this far? How many functions do I have? Actually, the outside function is the higher order function. Inside, I have this tiny function that gets any number and add 10 to the number. And from this function, I'm returning 10. So how do I get? No, what do I get if I print, hey, higher order function, just get maybe 5. As you can see, I am getting actually some other function. So this function is not yet invoked. So this function is actually the add 10. Have you seen the name? Add 10. So I have to call it by like this. Now, if I call it, I should get 15. Yes. Or actually, you can also invoke it here. You can invoke it, and you don't have to invoke it outside. So you can get 15. If you just also, for instance, have some kind of 25 and 10, 35. Yes, so this is the two definition I told you. One of the definition when you pass the function as an argument. And the second definition, when you return this function as in a value from a function, returning another function, or passing another function as an argument, as in a parameter, I'm sorry, is called higher order function. So what's the use to learn this? Oh yeah, because we are about to talk about the most common functional programming. Okay, great. I think I see some hand. Okay, do you have any question?
Yeah, Asabene, can you please repeat this nested function again?
Okay, with this one?
Yeah.
Okay. Okay. Is it okay? Is it clear up to here?
Yeah, up
Okay.
to passing the two function is clear.
Okay. So what I did actually, now this is just a function, the outer layer, and then inside I have created another function, add value, or maybe 10, add value, or 10. First, let me just add 10. Is that 10? Whenever it gets a number, it just adds 10 to that number, as you can see. Where this n come from the
First
outer
function. Yeah, okay.
Yes, so now, if we don't return this, there's no any way we can access it, right? So I have to return, but as a rule of thumb, we have to return something from a function, right?
Yeah.
So now in this function, what I have is actually in this function, what I have is another function. So I have to return it. So add 10, this is the only chance I have, or options I have. So if you just print now higher order function, and you can pass whatever you want, maybe 100, okay?
Okay.
But now
it should be 110.
Not yet, because when you call this function,
yeah,
it returns this value, this function. It makes this function ready. Let's see, as you can see, it gave me this. So to make use of this, I have to call it once, because this function is not yet called. That, as you can see, it hasn't been called.
Yeah.
But if you want to avoid this step, you can just call it inside here. Now, actually, I'm calling it here. You have a value, and then the value has been added in this function, and you call your function. Now you are actually returning a value, so I don't have to do this external calling. Is it clear?
Yeah, now it's returning 110.
Yes.
Yeah, it's clear now. Yeah.
Yes.
Thank you.
Great. Now let's move on to functional programming. Functional programming. This functional programming, like the map, filter, and reduce, are very powerful because you can write elegant code, very clean code, and it can solve quite lots of complicated problems for you. But actually, the list comprehension already can do what the map does. And the list comprehension can do everything what filter does, actually. Anyway, but it's very good to know. Now, again, these nums, do you remember the nums? I have 1, 2, 3, 4, 5. And again, if I ask you, hey, I want you to map this list to 1, to 4, to 9, and 16, and 25. I am asking you to do this. Then, hey, then I can go for, you can make your own function, or maybe comprehension list, or map. Okay, how does the map work? Map is a higher order function, like this. This is how you create a map. So it's a higher order function, a built-in function, and at the same time, a higher order function. It takes here function, And then the other side, it takes a list. Okay, now my list is going to be nums. But what's going to be my function? I can go for lambda. Lambda x, whenever there's x, change it to, it's a square. Oh yeah, this is what I need actually. Then I can store this, new nums. And if you print new nums, you may not get the list. Instead, you may get some kind of object. Oh yeah, map object. So to get the list, you can just do list. And then, oh yeah, we mapped it. Great. That's mapping. Now the same thing let's do for these countries. Yeah, I know everybody's in love with this list of countries. And let's do the higher order function. So maybe you can say countries code, then map. Did I tell you that this goes in the side of the countries? And in the other side, we have to have lambda function. You can call it C. Hey, C represent the one of the item or the country, then C dot upper, and then dot this slice up to 3. And actually, this is what you need to do. Then let's print again. Print countries code. And then again, you get object. So to get the list, you have to use the list method, the list. Yeah, as you can see, we got this. Can we do more? For instance, we can say, hey, just the country, and then to upper. And maybe we can also wrap it in. Now we are creating list of lists. As you can see, list of lists. Okay, is there any question?
Yeah, Asabene, may I ask something that why we are doing mapping? Like, in which cases we can use this map function?
Yeah, map is, as you can see, whenever you want to map, like you have these 5 elements.
Yeah.
And then you want to produce 5 elements again.
Okay.
It doesn't matter. It could be their square, or it could be it's double, for instance. But whenever you are expecting the same number of items.
Okay, but it doesn't matter like how it would be formed, like the cube or something else.
Yeah,
but
it doesn't.
It
Yes,
should be
it doesn't
only
matter.
the 5 items.
It doesn't really matter. As you can see now, for instance, I have you seen list of, from the countries list, I got this structure. But
Yeah.
if you count the total items, it should be again the same. From Finland, I generate this. From Sweden,
Yeah.
I generate this. So what it matters now, even I can change it also to tuple if I want. So you are just free to make or to produce anything. But the use case, whenever you want to produce the same amount or the same number of items.
Okay.
So can you tell me the association now between this and this?
Mm-hmm.
The association is actually from Finland. Finland just mapped with this data, with this tuple, and Sweden mapped with this. So how many items do we have here? The number of items we have here is equal to this, the number of items we have here.
Yeah, the 5 items, yeah.
Yes, that's when we want to use map.
But
okay. List comprehension also can do the same. Now, for instance, if you want to change this to list comprehension is already powerful. You can just take this, and actually we have created that already with list comprehension, you can say, then for C in countries. And then we are storing this for C in countries. What's, I think I need another more. Yeah, this is even more prettier than the map, but I should also teach you how map works. Have you seen? I got the same thing.
Yeah. Asabene, this is the one option. Is there any option like to do it in a more simpler way with pandas, or or only this one?
Panda handles different, but in Panda also, this is how you do it.
Okay.
Yeah, there will not be but Panda got this broadcasting. For instance, in Pandas, in NumPys, you have this for lots of easy ways of to do, but I think this is somehow straightforward. We loop, and there might be also simpler way using Pandas. Yeah, there might be. But
Okay.
most probably we use such kind of either comprehension list or map or some loops also in Panda series.
Okay.
Okay, let's go for filter. As you may imagine, filter is just to filter out. For instance, you can say filter, and filter again takes a function, lambda function. And if I say, hey, lambda, I want you to find the number, for instance, 0, that, and then I can say nums. So what am I trying to get here? Actually, I think it's better to make it n. Yeah, I am trying to get the even numbers from here. So I'm expecting 2 and 4, right? So if you just do this, list, and then I can print this out. Print, I'm expecting 2 and 4. And again, for instance, if you are like, we can change this to countries, and let's check the country that has land, right? So you may say land in, what was this, C. So that means it's a kind of, if this is true Z, then we filtered that out, and as you can see, Finland and Iceland. And if you are interested to countries without land, actually you may say land not in, not in. So then we will have countries without land. Yeah. This is how you make use of filter, and but still we can make use of this, the list comprehension. The list comprehension is also elegant. We've been doing that. If land in C, and we just want to print one C. And if you see again, we will see Finland and Iceland. Yeah, we've been checking that. So this functional programming is not that much a surprise. You don't have to use it. If you know list comprehension, you are just good enough, okay? And now I will introduce you reduce. Hey guys, reduce, you may understand from the word itself. You just reduce everything to a single item. For instance, you may have some fruit, you know, different fruits, mango, avocado, guava, whatever, and then you mix that together and you get a smoothie or a mixture of fruit juices, and that is, you change everything to one, right? So if you have a list of items, this we can change them to, we sum them up and it will be a sum of all the numbers, or we can just multiply them together and we can get the product of all those numbers. We can use reduce. So reduce And then again, the reduce take a lambda function, and the list nums. But this lambda should be x and y, and then we can say x plus y means we are actually adding all the items together. And this reduce is not available like filter or map globally, so we have to import it. And then I will teach you how to import from function tools, import reduce. So actually what go to the func tools module and import the reduce method. Now reduce, I'm about to use it. Then if you just store here total, and then let's see the value, print total. As you can see, 15, that's great. That means the total of this number. How about if we multiply them? We can just this change, and then you may get the multiplication of those numbers together. Yes, 1 times, that means 1 times 2, 2, 6, 24, 24 by 5, 120. Yes, it's sometimes common to put, if you are multiplying, change this to 1. If you are adding, change this to 0, but this is okay. Yeah, I think that's all about functional programming, and in the second session we will talk about modules, and that will be the end of the session. And before that, let's have a 10 minutes break. I will see you soon.